Hi, this is Dr. Graves from the CSUN Geography Department and geographyplanet.org. This is a video tutorial that will help you learn how to use Microsoft Excel to convert data that is served by law enforcement agencies that has been made anonymous. So in this tutorial, we will start with data that has been downloaded from the Los Angeles Sheriff's Department. I'm going to scroll down here, go ahead and note the URL of the data. Sheriff's Department moves it around, it seems like every other year, so it's hard to find sometimes. I've downloaded the 2019, or will download the 2019 file. That's a right click and open in a new tab, which seems to do the trick for downloading that. So pause and give yourself a moment to download. Okay, so I've downloaded the data. This is the 2019 Part 1 and 2 crimes for the LA Sheriff's Department. I'm going to widen a couple of these columns so you can see how that's done and what's going on in here. The columns that I'm particularly interested in is the category crimes, because I'm going to reduce that just to homicides, and then eventually this address column we're going to convert into something else. So let's go ahead and do the reduction and filtering of the data. Over here, click on the Sort and Filter button. On the Home tab, just click on the Filter option, and you will note the drop-down menus appearing in the column header for each column. Click on the down arrow, deselect everything by clicking next to Select All, and then just click once for criminal homicide. Click OK. And then that reduces the number of rows to 119, down from almost 164,000. I'm going to press Control A for Select All. That highlights the entire block of data. I'm going to press Control C to copy it, and then Control N, as in Nancy, to create a new blank worksheet, and then Control V to paste the data into a new worksheet. And I, at this point, want to save this worksheet and give it a new name. And here's the problem. Notice here in this column that the vast majority of the data has 00 in the block number. So if I zoom in here, we have 109,000 Long Beach Boulevard in Linwood. So that's on the 109th block of Long Beach Boulevard. Law enforcement authorities present the data that way in order to protect the identity of the victims of crime. And that is laudable and the correct thing to do. But if you're a GIS analyst and you're working with this kind of data, and you're trying to create something like a crime rate, having the data in this format presents a variety of problems that result in wildly inaccurate crime rate calculations. There's a tendency for all of the crimes to be on the even side of the street because 00 is an even number. And then in many instances, when the data is presented as a intersection, that all of the crimes that happen at a single intersection will be assigned to either a single zip code, census tract, or block group if there are multiple census tracts, block groups, or zip codes that come together at that intersection, because the point that is created during the geocoding process will fall into only one of possibly 4 different polygons. So then if you count the number of points that represent crimes per zip code or census tract, then they all pile up one single polygon, and there's a massive overrepresentation or overcount in that particular polygon and an undercount in the adjacent ones. So we're going to try to do something to fix that. You might ask, why not just use the supplied latitude and longitude? Well, you could in some ways, because these latitudes and longitudes are in effect also anonymous. They aren't very accurate, sometimes multiple blocks away from the reported address. And so you could use those as a general indicator of where a crime happened. But once again, by doing that, you may be overcounting or undercounting in a single neighborhood. And if you see, for example, here, these two longitude coordinates are both truncated, and so with these truncations, then you have a tendency for multiple crimes to show up all at the same latitude longitude coordinates, even though they were scattered about the neighborhood. So again, an overrepresentation in one place or another. So that's why we need to do it. How do we do it is the next question. Well, the first thing that I'm going to do is I'm going to highlight column G in order to get it ready to copy. So Control C, and then I'm going to move my cursor over to cell T1, where I'm going to paste this once and then twice. I'm going to keep that as the bad old addresses, and then in column U here, I'm going to use this as my column of addresses that I'm going to modify. I'm going to move over here so I can better show you how to do this. I'm going to call this old addresses here, and then this will be my working columns of data. I'm going to name them B, C, D, E, and we're going to do some calculations and reconfiguring of the data to make it mappable. So the first thing I want to do is sort A to Z, this column of data, and we find that this address is almost completely missing. So I'm going to take Los Angeles out and just put unknown in here. I don't want that one to appear in an analysis because we have no idea where it is. And then as I scroll down to the bottom, I find a number of these addresses here that are already good. These are ones that have been expressed as intersections, and they are absolutely fine. So I'm going to press Control C to copy them, and I'm just going to move them back over into the original address column. I'm going to call this one new. Got to remember to change that one to unknown up here at the top. I'm going to label that one as bad right away. And I can now return to focus simply on these. I want to sort that once again, A to Z, column U, so that I just have addresses that are numerical. I can actually delete these because I have copied them to where they need to go in the end. And at this point, the tricks begin, or the complicated steps. So here in this column U with A at the top, I'm highlighting the data. I'm going to press Control H, which is the find and replace tool over here. And what I want to have the computer do for me is to find every value that has 0, 0, and then a space, and replace it with a tilde and a space. And what that's going to do is give us a delimiter by which we can split column U into two. So I'm going to click replace all, 107 replacements. That's fine. That's actually a few short of what we should have, because now we see here that this is an intersection that begins with a numerical street name. This is also a good address, and that one is as well. There may be more, so now that we've identified that we have to do another step in order to make sure we get all of those. So I'm highlighting the data once again, and now I'm going to click on Data and Text to Columns, which is an extremely useful tool for a number of reasons in Excel. The text to column wizard appears. We want to leave it on the default delimited. Click Next. Select Other, deselect Tab, and in Other we want to type in a tilde and click Next and Finish. Now we have all of our block numbers minus the extra 0, 0. Let's sort this column one more time, A to Z. And down here at the bottom, we have the remaining addresses that make no sense. We're going to change this one randomly because it was given to us as 3400 to 3500 Hacienda Boulevard. Let's just change that to 35 and take these remaining three and put them over here in the good column. That was a Control X. And these are all complete at this point. Now, what I need to do is in one of these columns, I'm going to widen this up, column C, I need to ask the software to give me a random number between 1 and 100. So that formula is equals rand between 1, 99, and press enter. And then in column D here, I want it to multiply the value in cell U2 by 100. And then we want to add the values that we just created together to give us a new rendering of the address on that street. So that would be equals 100 plus 7, which now, because it's in the random number generator, changes every time. And then we're going to create new address column here that's temporary. So this is equals concat, which is a command to sort of paste things together. We're going to concat this 135, comma, and the value in cell V2. So now we've converted 100 South Wenton Street to 113 South Wenton Street. And even though that may not be the address where it actually happened, it is at least now odd. And so we'll have an equal number of these events on both sides of the street, a more responsible way of randomizing the addresses and making them more faithful to reality. I'm going to highlight all of this, press Control Copy, and double click in the lower right hand corner. That will complete this process for everything except these values at the very bottom. I want to highlight all of the new addresses I created, press Control C. I'm going to go back over here to column G, which is where my new addresses are supposed to go, and I'm going to click Home, Paste, and paste values. And now I have new addresses ready for geocoding in column G. That is how you do that, and this is the end of the video tutorial.